All right, good morning.
Who's there?
Dad, stop.
All right, we're gonna get going here. I wanted to share this with you. I think many of you guys are big pros at doing this, but just in case, I'm going to show you what Teams looks like and make sure that everybody knows how to turn things in. So I'm actually a student in Mr. Calano's class. This is what it looks like. So I go to assignments here at the very top. I click on assignments. Notice I'm a very bad student because all my homework is not turned in. But if you click on any homework assignment right here, notice at the very, here's the homework assignment. Notice at the very bottom it says add work. So for me, same thing. When you do your homework and now it's time to attach a picture of it, you click this blue button right here, click add work. You got to take a picture of your work. Once you take a picture of your work, I can't tell you where it goes on your computer, but down here it says upload from this device. When you click that button right there, my pictures are all right here, so I will send Mr. Calano a picture of a horse's butt. That's how you attach. Now remember, you may have 2 or 3 pages you need to attach. So attach them all. Make sure that the pictures are legible, especially for quizzes and tests, because I got to grade them. And then once it's attached, you simply click the button turn in right here. Notice I'm turning it in late. All right, so no, I won't actually send him a picture of a horse's butt. Okay, so that's how that's done. I just wanted to show you that. If you run into any problems or whatever, let me know, and I'd be more than happy to help you. So what we're going to do is we're going to get started on our homework, or go over our homework. So it was 5.59B. I know I did the first 3 or 4 in class yesterday. Are there any questions? Any questions on the homework?
Can you still go over the first 3? Because I left early, so.
I mean, I'm going to call out the answers, sure.
Okay, yeah.
Yeah. Anyone else? Anything you had problems on specifically?
Can we go over like 1 and 5 specific, or like, which one was it again? I think I did the wrong ones.
Okay, so you got to make sure you read it carefully. So it was 13 through 24 all.
Oh, can we go over 13 specifically? I don't know how to do that one.
All right, I will show you 13.
Okay.
All right. So 13 is 3p squared. Come on, mouse. 3p squared. Let me clear that. Okay. Plus 7p minus 6. All right. So when a is not equal to 1, we got to do a times c. A times c is negative 18. So that's 3 times negative 6, a times c. Now I'm looking for factor pairs of negative 18 that add up to a positive 7. So factor pairs of negative 17 that add up, factor pairs of negative 18 that add up to a positive 7. So let's see, 1 and 18, no way do I get to a 7. 2 and 9, though, can get me to a 7 if the 2 is negative and the 7 is positive. 9 minus 2 is positive 7. So there are what I'm going to turn my middle term into, just adding a p. So I rewrite this as 3p squared minus 2p. Where did I get the minus 2 from? Right here in the box. Plus 9p. I got the 9 from the box. and then minus 6. So all I did was rewrite this first trinomial right here as this right here. And all I did really was change the middle term, positive 7p to negative 2p plus 9p. Why? A times c is negative 18. The factor pairs of negative 18 that add up to positive 7 are a 9 and a negative 2. All right, now I put parentheses, 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 and factor each binomial. What comes out of a p squared and p, a p. What comes out of a 3 and a 2, a 1. I guess I could put a 1, but I'm going to choose not to. I'm going to divide 3p squared by p. That would give me 3p. If you're having problems on that division, then to ask yourself, what times p is 3p squared? 3p. When that's multiplied by that, I better get this. Negative 2p divided by p would be minus 2. Once again, if you don't understand that, then either think about it as multiplication, what times p is negative 2p, or division, negative 2p divided by p. The second one looks like we're factoring out a positive 3. That's the only thing that's common between them. 9 and 6 would be a 3. There's a p in the first one, but there's not one in the second one, so I'm not pulling out a p. 9p divided by 3 is 3p. And notice the magic that's forming here, that this will end up being exactly the same as here. What times 3 is negative 6? That's a negative 2. And look, magically they both match. The reason why they match is because this one is factorable. If it wasn't factorable, if I could not find two numbers that multiply to negative 18 that add to positive 7, you stop right here on the step and you put not factorable. Our final answer is we take what's inside parentheses, 3p minus 2. That's my first binomial, and my second binomial is everything that's left. And a p and a plus 3, that's what goes in the second one. Aiden, questions?
I think I get it now.
Cool, because we're going to do more of it today, too.
Okay, good.
All right.
Thanks.
No worries. All right, let's go over the answers. Here we go. Well, you just saw 13. It was 3p minus 2 times p plus 3. Number 14, 2c plus 3, 2c minus 1. Number 15, y minus 1, 4y plus 3. Number 16 is not factorable or prime. Number 17, 5 minus 3x, 1 plus 2x. Number 18, 3 plus 4k, 3 minus 2k. Number 19 is not factorable. Number 20, 7 plus 2s, 1 minus 2s. Number 21, oh, we had two variables here. We handle it the same way. 3m plus 2n times m plus 3n. Number 22, 2p minus 3q and p minus 2q. Number 23, 2x plus 3y, x minus y. And the last one, 5a minus 7b and a plus b. All right, we're in the heart of the challenging material for the next.
Mr. Chartier,
Yes.
can you go over 22 again? I didn't hear it, sorry.
2p minus 3q times p minus 2q.
Okay, thank you.
You're welcome. We're in the challenging material. This is not easy. This is challenging stuff. If you understand the process, I guarantee you things will be fine for you. If you don't understand the process, this will be. I mean, you can pretty much guarantee that you will fail this chapter. You have to understand the material. All right. So today we're skipping 510, and the reality is 510 and 510 is a precursor to 511. I just teach it all in one little lesson, 511. 512 is what this entire book is about. We're going to do 2 days, maybe even 3 days of it, depending upon, most people catch on to it pretty quickly. But 512 is what this entire chapter is about. It all leads up to why in the world are we doing this thing called factoring? It seems like a ridiculous thing, you know, just changing a trinomial quadratic into two binomials. The reason we do that is because of 512. It actually has a purpose, and we'll reveal that to you tomorrow. All right, chapter test looks like next Wednesday. Worksheet for homework tonight. There's going to be 10 problems. 10 problems. If there's the messiest assignment of the entire year, it's today. Today is going to have more parentheses than you've ever seen in your life. So today, the actual method of what we're doing is not that much different than what we've already done, but boy, does it get messy. It gets really messy. Be ready for it. Okay, so the worksheet is posted on the Google Teams, or got Google Teams, Microsoft Teams. And if you have any problems pulling it up, just let me know. Here we go. So it's called factoring using several methods. So in other words, we're going to factor, but then we're going to factor it using 2 or more different techniques. We're only going to use 2 techniques. All right, so yeah, what we're really going to do is take what we've done for the last 2 days and just make it more difficult. It actually only adds 1 extra step. So for those of you that have a pretty solid command of what we're going to be doing, you're going to breeze through this material. For those of you that are just about to get to complete understanding of this, today will be the class you get to that. And for those of you that are lost, today is going to be even more difficult. All right, here we go. So we've done factoring of trinomial quadratics like this before. What we're going to do now is we're going to make it more complicated. We're going to multiply everything by another number. So notice, if I put parentheses around this and I multiply the whole thing by 2, well, I would have to use the distributive property, and you would get 12x squared minus 22x plus 8. All I did was take each term and multiply it by 2. Tonight for homework, instead of having the trinomial look like this, it's going to look like that. So we're actually going to have to do 1 extra step before we factor, and that is divide everything by a common factor. So what I'm going to do is I'm going to give you this and ask you to factor it. What's your first step? Your first step is going to be to factor out, in other words, divide every term by a common factor. In this case, that common factor is 2. So all I'm going to do, the difference between last night or last 2 nights homework and this one is that there will be a common factor that you can factor out. Oh, by the way, it will make your life easy. If you don't factor out the common factor, you're multiplying 12 times 8, 96. Good luck with that. Now when we multiply A times C, we get 24, a much easier, friendlier number to deal with. If you do not do this and you leave it as an unfactored form, you're going to get a really, really large number. Some of the ones that I'm going to give you tonight for homework, this number A or C is going to be in the hundreds. You're absolutely positively going to want to factor out a common factor first. Otherwise, it becomes too unmanageable. Okay, so I'm still going to factor 6x squared minus 11x plus 4 the way that I just showed Aiden. But the only difference is that the first step is you're going to factor out a common factor. I guess the easiest way is just to show you a bunch of examples. So here's our steps that we're very familiar with that we've been using for the last 2 days. Here's our start. 18x squared minus 33x plus 12. Look at the coefficients of all those numbers, 18, 33, and 12. 12 is constant. Is there any number that goes into 18, 33, and 12? Somebody?
All of them.
What do you mean all of them?
All. Yeah, all.
What do you mean all of them? Is there any number that goes into 18, 33, 12? What's that number?
3.
3. So we're going to divide everything by 3. So 18 divided by 3 is 6. 33 divided by 3 is 11. And 12 divided by 3 is 4. Notice that's what my first step. So the only difference between the last 2 nights homework and tonight is this fact that I now have a 3 sitting there all by itself. Typically, the issue is that you forget that this 3 is here, and somehow between this and the very last step, this 3 disappears because you just get lazy and you're not paying attention. But truly, the only difference between last night's and tonight is this 3 is just going to sit there for the entire problem to the very end. All right, so here's how it's done. Multiply A times C. 6 times 4 is 24. I got to think of factor pairs of 24 that add up to negative 11. So I'm not going to consider any of the positive factor pairs. 1 times 24 would add up to 25. I need negative factor pairs. So I'm only going to consider the negative ones. Negative 1 times negative 24 is a positive 24 multiplied together, but when added is a negative 25. One of these adds up to negative 11. Check it out. It's negative 3 and negative 8. Negative 3 times negative 8 is positive 24. But when we add them, we get negative 11. So that is what we're going to substitute in for negative 11. Negative 3x and minus 8x. I'm going to take this whole big honking yellow thing right here. I'm going to rewrite it, and I'm going to rewrite negative 11x as negative 3x minus 8x. And then I'm going to continue on with the process. Here's the problem. Before, we didn't have these two sets of parentheses. Now we do. Now I'm going to add 4 more sets of parentheses. Right? That gives me a total of 6 parentheses. I'm going to have a lot of parentheses floating around. So just be ready for that. Be ready for that. All right. Aiden, you need to sit down and you need to pay attention. All right, here we go. So notice all those parentheses are floating around. That's a lot of parentheses. A lot of parentheses. I mean, in fact, if someone that gets lost, it's because there's so many parentheses. So many parentheses. Okay. Now we're going to factor out each one. Each binomial we're going to factor separately. Let's see, a 6 and a 3. Well, I can pull out a 3, and remember an x and an x. So if I factor out a 3x from the first binomial, what times 3x is 6x squared? That's 2x. What times 3x is negative 3x? Negative 1. 3x times negative 1 is negative 3x. 3x times 2x is 6x squared. On the second one, remember, when this term is negative, we're going to factor out a negative number. So I'm going to factor out a negative 4. If I pull out a negative 4, negative 4 times 2x is negative 8x. Negative 4 times negative 1 is a positive 4. Look at all those parentheses. It can become slightly confusing. To write our final answer, this 3 stays there with that parentheses. But I'm going to have 2x minus 1 and 3x minus 4. Look at all those parentheses. That's a lot. Okay. The only difference between what we did last 2 nights and today is this 3 is hanging out here. So what generally happens for the smart students is they're like, well, if the only difference is this 3, and I don't want to deal with 6 sets of parentheses, then I'm going to just forget about this 3 until the very end. Okay, I will admit that I did that when I was your age as well too, because I didn't want to deal with 6 parentheses. So all I did was, okay, I knew that 3 was here, and at the very end, I just tacked on a 3 to my answer. Is that a viable technique? It is. The downfall of that technique is you got to remember to tack on the 3 at the very end. So once again, if you don't want to deal with all of these parentheses, because there's a lot of them there, then you can leave off the 3 as long as you put it back in at the very end. Now, just be really cautious with that, okay? It can definitely run you into problems if you're not paying attention, okay?
So it's basically the same as yesterday. There's just another number outside that we have to add.
You got it. And where does that number come from? It comes from the very first step. So the reality is it's not that much more challenging than the very end. Or it's not much more challenging the last 2 days. We better see another example. Hey, look at this one. Notice if you didn't factor out a common factor, you'd be multiplying 8 times 20. That's 160. That number is huge to consider factor pairs. So absolutely 100% do this. What goes into 8, 36, and 20? Somebody. Biggest number.
4?
4.
8? Oh, wait, no. 4,
8, yeah, it's 4. 8 doesn't go into 36 or 20. All right, so 4 goes into both. So I factor out this 4, and I get this nice friendlier trinomial, 2x squared and a negative 5. So that is easily factorable, right? If you didn't factor out that 4, 8 times 20 is negative 160. It's just a huge number to consider. So this technique works well. Like I said, for the smart students, they're going to look at this, what I'm about to do, and they're going to say, why don't I just leave the 4 off until the very end? For the rest of you, if you're like me, and I mean, I tried this, and then eventually I would forget to put the 4 in, and I would get it wrong. So for many of you, I'd recommend leave the 4 in, and I will leave the 4 in. But for those of you thinking ahead, yes, I'll allow you to leave the 4 off until the very end. All right, a times c is negative 10. I need factor pairs of negative 10 that add up to negative 9. Well, let's see. The obvious one would be 1 and a 10. That could get to a 9 if the 10 is negative and the 1 is positive. 2 and 5 don't get me anywhere close to that. All right, so it's negative 10 and a positive 1. Negative 10 and a positive 1. And remember, when one of them is negative and one of them is positive, we like to write the negative 1 first. Okay, so let's see. We're going to write this as, I'm going to leave my 4 here so I don't forget it. 2x squared, instead of writing minus 9x, I'm going to write plus 1x minus 10x, and then the minus 5. Okay?
Aiden, put your really cute dog away.
Hey, Aiden, if you want to sit here for the entire class and mess around, I would much rather you not come live.
I have my notebook right next to me.
You're going to disturb the rest of the students, right? Please stop.
Okay, fine. I'll shut my camera off.
All right.
See
So,
you guys.
parentheses, 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 parentheses. All right, and this is usually the step where I lose some people. They're like, why do you have so many parentheses? It's because of this 4. Because the 4 is being multiplied by everything. So these outer set of parentheses must remain. Now we factor each binomial separately. Julie made the comment the other day, will I always pull out an x from the first binomial? Yes, you will, or a q or a p or a z, whatever the variable is. The second one will never have that other variable, as long as there's only one variable. You noticed last night you had a couple with 2 variables, and that's why that second one had a variable. But when there's only one variable involved, x, then that first binomial is the one that you pull out the x, the second one you don't. So what times x is 2x squared? 2x. What times x is x? A positive 1. On the second one, we got a negative. Oh, I messed up and I put the negative second. If you occasionally do this, and you will because you're not paying attention, just remember, when the second binomial, the first term is negative, you got to pull out something that's negative. So it looks like I'm pulling out a negative 5. So I pull out a minus 5, and I get a matching 2x plus 1. If we pulled out a positive 5, you would get negative 2x minus 1, and that wouldn't match. Okay, so the final answer, this 4 still stays here. I get a 2x plus 1 and an x minus 5. And that's the process. So Josie said, so the only difference is that first step, and the answer is yes. That's it. All right, any questions?
So for the second, Mom. No, I
I'm not
didn't
sure I
put
can answer
peanut
that
butter
one.
on my ball for the dog to lick off. Sorry. So I should have muted my mic. For the second
I think
one.
so. Yes.
For the second one, I'm confused still.
When you say second, what do you mean the second? Step 2?
Yeah, step 2.
Do you understand where I got negative 10 from?
Yeah.
Now I want you to think of negative 10 and tell me every number, every factor pair of negative 10. Like what numbers multiplied is 10?
5 and 2.
5 and 8. Oh, 2.
5 and 2 and
1.
2.
1 and 10.
1 and 10.
So notice the only way when you add those numbers up that you get to a negative 9 is when the 10 is negative and the 1 is positive. Because positive 1 times negative 10 is negative 10. Positive 2 times negative 5 is negative 10. So these two numbers right here, do you see where my mouse is?
Yeah.
These two numbers multiplied together must be negative 10. These two numbers multiplied together must be negative 10. There's other options here. And the 2 could be negative and the 5 could be positive. The 2, please erase that. The 2 could be positive and the 5 could be negative.
What?
Right? The 1 could be negative and the 10 could be positive. Okay?
Well,
So
no,
that could happen. But there's only one of those combinations that adds up to negative 9. For some of you, you're going to have to go through every single possibility. A negative 1 and a positive 10. A positive 1 and a negative 10. A negative 2 and a positive 5. A positive 2 and a negative 5. And then see which one adds up to negative 9. So the one that I got adds up to negative 9 is a positive 1 and a negative 10.
That's what I got.
On step number 3, when I rewrote it as these two numbers right here, positive 1 and negative 10, and I wrote them right here. You're like, well, where is the 1? Well, I just leave off the 1, right? I mean, I can put a 1 right there if I want to, but I just choose not to write that 1. Okay? All right.
Okay, I understand it now.
All right, cool.
You sure?
Aiden, let me ask the questions. All right, here's another example. If you want to write this down and do this with me, do that, please. 8x squared plus 34x minus 30. 8x squared plus 34x minus 30. Step number 1, is there any number that goes into 8, 34, and 30?
Four.
4 does not go into 34 or 30.
2.
2 goes into all of them. So 2
Yeah.
is the largest number that goes into all of them. I'm going to pull a 2 out of every one of these terms, 8, 34, and 30. So if I pull a 2 out of each one of those, well, that would give me 4x squared, that would give me 17x, and that would give me negative 15. Everybody understand what I just did there? Okay, so step number 1, A times C. 4 times negative 15 is? 4 times negative 15 is? Negative 60. All right, so that's a pretty big honking number. We're trying to get to positive 17, positive 17. So if I list every possibility, I'm going to do some scratch work here. If I list every possibility, right, I'm trying to get to the number positive 17. I'm trying to get to positive 17. So to get to positive 17, I consider every possibility. 1 times negative 60, or negative 1 times positive 60. If I add those, no way in heck do I get to a 17. So that didn't work out. How about 2? 2 times negative 30 would be negative 60. Add those, we don't get to 17, nor if the 2 were negative and the 3 were positive. That didn't work either. So that didn't work. 3 goes into 60. 3 times 20, and I think you can see that we're going to get to a 17. We want to get to a positive 17, so the 20 is positive and the 3 is negative. So this would be the process that I would do in order to figure that out. Okay, now I'll give it to you nice and pretty looking, right? So the factor pairs would be a negative 3 and a positive 20. So negative 3 and a positive 20 get me to this positive 17. So I rewrite this whole darn thing in yellow here, but instead of writing 17x, I'm going to write negative 3x plus 20x. The thing that I put in the box there, you just attach an x to. You're supposed to stop me if you don't understand. Okay, now we add those 4 sets of parentheses, and boy, does it get messy. Right? I add those 4 sets of parentheses. Parentheses around the first 2 and the last 2. Now I factor each binomial. Julie said, will there always be an x? Yes, there will always be an x that you will factor out of the first one. But you also got to look at these 2 numbers, 3 and 4, and see if there's anything they have in common. The only thing they have in common is a 1. So you can write a 1 if you want. I'm going to choose not to. I'm just going to write an x. What times x is 4x squared, 4x? Because x times 4x is 4x squared. What times x is negative 3x? Negative 3. X times negative 3 is negative 3x. On the second one, there will not be an x to pull out, but there will be, in this case, 20 and 15, will be a positive 5. If we pull a 5 out, 5 times 4x is 20x. 5 times negative 3 is negative 15. If there's a step that causes problem, it's this one right here, this factoring right here. So the quicker you can get to competence or mastery of this, the easier this will all seem. The rest is pretty straightforward. I mean, the next step, literally, we just write what's in parentheses here, and we'll write what's not in parentheses. The 2 is still there, so I put 4x minus 3 and x plus 5, and we're done. Feeling better? All right. I only have 2 more examples to do. 2 more examples to do. 2 more examples to do. All right, let's do them. All right, we'll do the one on the left first. Write that one down. 4x squared minus 18x plus 20. 4x squared minus 18x plus 20. All right, for those of you that are doing absolutely nothing, right, please stop, grab your pencils, and let's do this work. All right, here we go. Let's see, 4x squared minus 18 and 20. The number that goes into all of those, 4, 18, and 20. 4, 18, and 20. Let's see, a 2 would go into both of those. Anything else? A 4? 4 doesn't go into 18. So it looks like 2 is the only thing that goes into everything. A 2 that goes into everything. So we're going to pull out a 2. We're going to pull out a 2. So we pull out a 2. Oops, that shouldn't have shown up. We pull out a 2. 2 times 2x squared is that. 2 times negative 9x is that. And 2 times 10 is 20. That's our start. That's how we start. Haley, you paying attention? You sure? Okay. All right. Here we go. Let's see. Now we're going to look at this. A times C, 2 times 10 is 20, right? A times C, 2 times 10 is 20. And we think of factor pairs of 20 that add up to negative 9. So if we do factor pairs that add up to negative 9, well, the only way you get to a negative if both numbers were negative. So in other words, like a negative 2 and a negative 10 multiplied together are positive 20. But when you add these two, we get to negative 12. Well, that didn't work. I didn't even consider 1 and 20. No possible way. Aiden, move the pencil. All right. The next thing I should consider, let's see, 3 doesn't go into 20. 4 goes into 20. 4 times 5 is 20. So let's consider 4 and 5. Negative 5 and negative 4. Check it out. Negative 5 plus negative 4 is negative 9. That does work. So negative 5 plus negative 4. So that's what I want to use, a negative 5 and a negative 4. So I'm going to rewrite this part of the trinomial right here. This part right here, negative 9, as negative 5x and negative 4x. Okay. Now we add that whole bunch of parentheses. Parentheses, 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 just a whole bunch of parentheses. A whole bunch of parentheses. We look at this first one. Let's see, 2x squared and minus 5x. Hey, the only thing that we can pull out of a 2 and a 5 is a 1. That didn't get us much. But an x squared and an x, we can pull out an x. Okay, so I'm going to pull out an x on the first one. On the second one, I can pull out a negative 2. So I'm going to pull out an x on my first binomial. I'm going to pull out a 2 on my second binomial. X times 2x is 2x squared. X times negative 5 is negative 5x. We're going to pull out, remember, when this one is negative, we're always going to pull out a negative. So I pull out a negative 2 times positive 2x is negative 4x. And negative 2 times negative 5 is a positive 10. Okay? At this point, we're basically done. The answer is going to have a 2, right? The answer is going to have a 2. Hey, I'm getting really tired. If you'd like to teach this to yourself, I can stop at any point. For those of you more concerned about making your neighbors laugh, for those of you more concerned about drawing things on my board, that is very disrespectful. Are we going to take this seriously, or do we want to stop right now? Erase my board, please. One of you did this. Erase my board, please. So the person who did that, do not do that ever again. You're in 9th grade. You're in high school. If you fail this class, you fail high school until you make this class up. Let's start taking this more seriously. Sorry for the rest of you that were paying attention. Okay, here we go. So our very end right here, it ends the same way each time. The 2 is going to remain there. What's in parentheses here, notice it's the same thing, 2x minus 5. And what's left is an x minus 2. What's left is an x minus 2. So 2x minus 2, and then the 2x minus 5. And once again, I haven't shown you this too many times. It doesn't matter the order that you write what's in parentheses and what's not in parentheses. Most of the time, I always write what's in parentheses first and what's not second, but it can go in either order. All right, we have time to do one more. One more. All right, you can already see the answer here. Go ahead and write this one down. And I'm just going to point out, notice, if we did not factor out what's in common, we would be multiplying 60 times 30, right? That's 1,800. You would have to be thinking of factor pairs of 1,800. That's crazy, right? All right, it'll be slightly more convenient when we factor this one out, slightly. All right, so as you can see down here, we already can see the common factor is a 5. So we pull out a 5. 60 divided by 5 is 12. You guys have to be touching the buttons in order to do that. That's not a mistake. That's you actually doing something. Please stop. AC is 12 times -6, which is -72. I'm now thinking of factor pairs of -72. That is a big number, but we can do this. So what will we be considering? 1 times 72, 2 times 36. Let's see, 3 would go into 72 24 times. We're going to go through every single possibility until we get to a -1. We're trying to get to -1. We eventually get to a possible 9 times 8. 9 times 8 is 72. And if you add 9 and 8, well, you get 17. But if one of them was negative, we can get to that -1 right here. -9 plus 8 is -1. 8 minus 9 is -1, or -9 minus, or plus 8 is a -1. So we rewrite this step right here as 5 times 12x squared minus 9x plus 8x minus 6. Now we put our parentheses. Parentheses around the first 2 terms, parentheses around the last 2 terms. We factor out what's in common. 12 and 9, what's in common between 12 and 9 is a 3. As Julie always says, we'll always be pulling out an x. So we're going to pull out a 3x from the first binomial. On the second one, the only thing that's common is a 2. 8 and 6 would leave me with a 2. So we pull out a 3x from the first one, a 2 out of the second one. What times 3x is 12x squared, 4x. What times 3x is -9x, -3. What times 2 is 8x, that's 4x. What times 2 is -6 is -3. From there, you can see where I get the answers from. 4x minus 3 is here, and what's not in parentheses is 3x plus 2. That's all I have for you.